Hello and welcome back. In this session, we're going to learn array rotation using Python. Let's first go through the problem statement. Problem statement rotate a given array to the right by k steps, where k is a non-negative integer. And we have a sample input in line number 4. Okay, an array containing 1, 2, 3, 4, 5, 6, 7, 8 elements. And we are asked to rotate 4 times. When you do that, uh, 25, 30, 35, and 40, they're going to come toward the beginning of the array, and then 5, 10, 15, and 20, they're pushed toward the end of the array. That's what rotation means, because if 40 comes out first, uh, in right rotation, right shifting, uh, then basically um, 40 is the one that goes to the beginning of the array first, and then next time 35 comes, uh, and then 40 is pushed toward right, and 25 will be the last one, because that's k is equal to 4, right? Because 4 times we are pushing 4 elements. And then algorithm is basically, it's a pretty interesting algorithm. We reverse. Well, first, if you'd like to pause the video and then do the algorithm first and come back, that's a good one to try, because that's the thing that benefits you best, while preparing for any interview, because it stresses your mind, and then you tend to remember after you see somebody else's solution, or if you come up with your own solution complete, that's even the best thing to do. Okay, so I'll give you that time, and when you come back, then the algorithm is going to be as follows. Okay, first we reverse the entire array. Okay, and then uh, we reverse the first k elements, because if we reverse the entire array, this 40 is going to be in the beginning, after the 35, 30, right? But that's not exactly what we want. We want this one. That means if 40 is in the beginning and 35 is the second position, it has to be reversed again. That means we are reversing first k elements. Okay, but we can't reverse all of them. If you do reverse twice, then we're going to get the original one. We don't need that. Okay, we need the result that we get by shifting. Okay, and then in the not the second half, but the remaining elements, beyond after k, remaining elements will be, if the length of the array is n, remaining elements will be n minus k, and those will be also like 5 in this particular case, 5, 10, 15, and 20, right? Those will not be in that order, because those will be also reversed. It will be 20, 15, 10, and 5, and so we need to reverse that as well. So we're reversing that. So 3 reverses, one for the entire array, and then for the first k element, and then for the remaining elements, which is n minus k, n being the size of the array. Okay, so now complexity analysis is also very straightforward. We are doing 3 reverses, and the maximum uh, maximum uh, reverse that we need to do, maximum number of elements that we need to handle in each 3 reverses is n, because first we reverse all the elements in the entire array, and then next time k is less. At most it can be just it could be just a n, and then another is n minus k. Okay, so the max value is always n, n being the length of the array again. So that's why the time complexity is order of n, and then space complexity, we don't add any additional space. Okay, whatever given space is there, we make use of that. We just swap the elements. Okay, that means our space complexity is, it's constant. Okay, so which is equivalent to saying order of 1. Okay, so this completes the problem explanation, and now let's quickly get started with our uh, rotate array. I have rotate array Java there, that's why I get this one, but Now our extension is going to be this one. Okay, let's get it started. Let me define, this is Python, so let me first define my reverse function, and this is going to take numbers, the array, start index and end index. And what do I do inside? I check if start is less than n. If that is true, then I do something. What is that do something? That something is, in temporary variable I store the number in start index, and I get I get the value of nums at n index to start index, because I'm swapping, and then now I can change the value of number in n index with 10, because that's the one in the start index, right? So we swapped it. Okay, once we swap it, we also need to change our pointer start. Our pointer start is increased and n is going to decrease. Okay, and is going to decrease. Okay, now next function, which is rotate, that's what I need to do, and I'm rotating this my array k times, and basically, well, we do one more thing. We do this magical thing, you know. This saves time. If your k remainder length, our effective k is going to be the remainder of k divided by length of the array. Because let's say I have an array containing 4 elements, and I provide the rotation 8. If I rotate 8 times, I'm going to get the same original array. So basically, rotating 8 times is equivalent to rotating nothing, doing nothing. Okay, so that's why it's important to do this one. And rotating any multiple of n is equivalent to not rotating the array. Okay, so that's why we're taking this remainder operation. We just need to rotate always uh, at most. Well, at most it's going to be length of array minus 1. That's the maximum we need to rotate. If we rotate n times, we're going to get the original one. So that we don't have to do, right? Even if, so that's what we're taking care of here with this simple, very simple statement. That's interesting, actually. You know, if you're studying computer science, like a undergrad freshman, or in even high school, or even earlier, it might take a while to kind of pop up this thing in your brain, and this is true for me as well. Okay, I didn't get this thing coming to my brain in my first attempt. Okay, and I'm guessing it might not have come to a person who first proposed this in the first attempt. So I think you don't have to really worry about it. More we play, more intuition and ideas we get. But here we we don't always invent things. We get the core algorithm, we borrow that, and then we implement that. We do the coding primarily. But it's always a good idea to actually spend time and then try to come up with a one algorithm. That's always. But here in video we have limited time. I can only upload videos of certain sizes, so I need to continue. Okay, so now I'm going to call reverse 3 times. First I'm reversing the entire that is my I breaker. I don't need that now, not I breaker, but the I rest. For I rest, reverse nums. I'm going to reverse the entire array, so that's how I specify nums -1, right? 0 to -0 to length -1 gives me all the array, all the elements of the array. And next time I'm going to reverse the first k, and that first k I say this way, 0 to k -1. If index starts from 0 is, I just need to go to k minus 1, and then last one is nums. I already did up to k minus 1. Now I do from k to k included, length of nums, and then minus 1. That's it. Now all we need to do remaining is our usual main method, the driving method. Okay, let me first, let me call it my nums, and let me specify numbers, and we have numbers ready. Okay, we can just copy paste. I could actually copy paste that square bracket also, but I already have one here. So I'm going to do this one, and I'm going to delete that one over here. Okay, and then I call my rotate. I rotate my array. I'm going to specify 4. Okay, so I'm done. After I rotate, I just print my nums. Okay, Java I need to just iterate through my array, but in Python I don't have to. It just takes care for me. Now I write my last this check, and I'm checking in order for the interpreter to be able to find main and execute it. Okay, so that our main core logic can be implemented, and I'm going to do this one. Okay, so main calls, this calls main calls rotate, rotate calls reverse, and we are pretty good. Okay, let's apply that. We get errors. If there are errors, .python, let's see how many errors we get. Yes, sure, line 20. We're getting something. What does it say? Init is not defined. All right, let's see, let's get line numbers. Init is not defined. If init is equal to main, it's not init, actually it's a name. Okay, hang on, not that, yeah, if name is equal to main, that's what I'm supposed to type. Okay, let's run it, and let's compare with our expected result. 25, 30, 35, 45, 10, 15, 20. That's exactly what we need. And this completes our session for Python implementation of array rotation. I will see you in the next video for the next problem.